In this question, we're asked to predict some compounds that might form from nitrogen and fluorine, hydrogen and chlorine, or lithium and nitrogen. But we're only asked for molecular compounds. So if there's a metal and a non-metal, it's going to be an ionic compound, and we don't have to consider that one, such as lithium and nitrogen. Now, there are some general rules. To be frank, I would prefer not to use these general rules. I'd prefer to allow you to see them on your own. However, I do want to show them here because they're necessary to solving this particular problem. So some general rules are: hydrogen has one electron, and this is the Lewis structure of just the element hydrogen. This likes to form one bond, no lone pairs. Because it likes to be like helium, and if it gets one bond here, it'll be sharing two electrons, and it'll have its duet, as opposed to an octet, if you will, and that's a stable form. If you look at carbon, and this applies to 4A nonmetals, which is mostly just carbon, but it's sometimes silicon as well, even though that's a metalloid. Carbon likes to form 4 bonds, no lone pairs. So it likes to have each of these 1 electrons form a bond with something else, such as if it was with hydrogen, it would be CH4, and therefore it would have its octet, its 8 electrons. If we look at nitrogen and the 5A nonmetals, sometimes applying to phosphorus, although phosphorus could expand its octet in some cases, okay, we have a lone pair and 3 bonds. So nitrogen likes to form 3 bonds, 1 lone pair. If we look at oxygen, oxygen likes to form 2 bonds, where it has the 1 electron, and have 2 lone pairs, such as in water, H2O. So 2 bonds, 1 lone pair. And this often applies to sulfur as well, although again, sulfur can expand its octet because it's in period 3 or lower on the periodic table. And then finally, fluorine. Fluorine has 7 valence electrons, so therefore its Lewis structure looks like this. I should have pointed out before that these dots are representing the valence electrons. And it likes to form 1 bond with this 1 electron, and then have 1, 2, 3 lone pairs. This information can be useful to solve this particular problem. However, I will tell you that if you practice with your Lewis structures, doing it the methodical way that I'll show in several of these videos and you may have already seen, you will come to this conclusion on your own. And in my opinion, that is a better way to learn it. However, here, let's take a look. So, we have nitrogen and fluorine. Nitrogen likes to form 3 bonds and have 1 lone pair. Fluorine likes to form 1 bond. So when nitrogen and fluorine bond, we have nitrogen here, like so, and it will bond to 1 fluorine, like this, another fluorine, like this, and a 3rd fluorine, like this. Since these are both non-metals, it does form a molecular or covalent compound. The chemical formula is NF3, and this is the Lewis structure here, although we usually report the 2 dots between the elements as dashes. And the name is nitrogen trifluoride. Tri for 3. So for covalent molecules, we use the prefixes to tell how many there are. So this is nitrogen trifluoride. Hydrogen and chlorine. So hydrogen and chlorine can form a molecular compound. And the formula is, we have H, which likes to bond like this, and Cl is the same as fluorine, so Cl will look like this, and we get HCl. This could be called hydrogen chloride. It's probably more commonly called hydrochloric acid. Lithium and nitrogen don't form a covalent compound because we have a metal and a nonmetal. You must have two nonmetals in order to form a molecular or a covalent compound. So for this one, we don't need to do anything.